In this problem, we are asked to analyze the addition pattern class. So some of the pieces of information that we have here, first of all, we are told that this addition pattern object is constructed with two positive integer parameters. And as we can see from this example right here, we know that the first parameter is the starting number, and the second parameter is the value to be added. So for those of you that have learned about series and sequences, this should remind you of the arithmetic series problem, or sequences rather. So there are a couple methods that we need to deal with in this problem. The methods that we have are the current number, next, and previous. And when you write a full class like this problem, you don't have the ability to change the names of these method names. Unless otherwise specified, you can use whatever names you want for variables, but you have to use those method names that are given. Now, when we go down and look at this table here, we can see how all of the different methods are going to be used. Now, this is really valuable when it says value returned blank if no value. So in these different cases here, you can see that a value is actually returned. And in all of these cases, the method that is called is the getCurrentNumber. So we know the getCurrentNumber is going to return something. We can also see that in all of these guys here, we don't have anything returned. So we can see that both next and previous don't return anything, which means that they are void methods. Another thing that is useful from looking at this chart of information is that once we have reached a point where the current number has been decreased enough by successive calls of previous that we are down to where we started at, that if I call previous again, I stay the same. So that is something else that I have to make sure that I include in my code. Now, when we say we want to write the complete addition pattern class, the things that we need to have is we need to have a class header, we need to have those private instance variables, we need to have a constructor to set up those variables, and then lastly we need to have any methods. And in this problem we have 3 methods that we need to have. So if you haven't yet written your code, then pause the video and go ahead and give it a try, and then repause or re-unpause when you are ready. Alright, so if we take a look at this first page, this was just my general planning. I was taking a look at the variables I needed to have, the methods I needed to have. So this is like what I talked about just a minute ago, but this is how I would have written on my paper if I was taking this problem myself. Then when I go ahead to do the next part where I write my actual code, some things to notice. So first of all, we need to have our class header. We need to have our variables. Notice the visibility modifiers. So we have public for the class header, the constructor, and all of these methods that are called outside of the class. And then we have private, which is used for our instance variables. If you don't use those correct visibility modifiers, you will actually lose that point. Now, these variable names that I used, start val, current value, and add amount, you can use whatever you want. That was just what I used. In my constructor, this is where I am taking the value that is given to me and I'm assigning it to my actual values. Now, let's say, for example, we had used these values start val. What you could have done over in your constructor is you could have said this dot start val equals, and then you could have said start. You could have also said start val. Sorry, my handwriting's atrocious. And then right here, you could have used that same name. So remember we talked about how you can go ahead and do that. That is perfectly acceptable. So now we have these 3 methods down here. My current number, like we just talked about a minute ago, this method is going to return the current value. So we just have to make sure that whatever you called this value for the current value, that's what you're returning. And also recognize that that current value has to be equal to your start value at the beginning. Next, we have our next method, and our next method is always going to add on this amount and update the current value. So that's what we've got going on here. And then last, we have this previous method. And what's really integral about this method here is that we have to first verify that we can, in fact, subtract before we actually do it. A common mistake on this problem is that people will do this line first, and then they will check if the current value is less than start. And it doesn't work that way. Once you actually call this minus equals, you have actually subtracted it. So that is why right here I am saying, if I were to subtract it, would it still be valid? And if it would be valid, then go ahead and do it. Otherwise, don't do anything. So once I have reached that minimum value, I could call prev over and over and over, and it would never change. It would just stay at that starting value that we began the problem with. So here I have the rubric for us. And what you can see when you look at this rubric is, first of all, that we have a point for that correct class header. We have a point for those variables, a point for our constructor header, a point for actually doing the constructor work correctly. Then notice that all of these are specifying that you have to have those right public or private words. So it's really important that we are paying attention to that. Then our next set of points relate to the method headers for those methods, as well as the implementation. And notice that we even have a full point, making sure that we don't let that current value go below the start value. All right, so this was it for our first FRQ for Unit 5. Tonight we have 2 FRQ problems for homework. Ideally, you'll do both of them tonight, but if that's not possible, then do one tonight and one tomorrow. All right, that is all. Thank you.